Hello everyone, we are students of UTN Paraná. My colleague is Lautaro Ubiedo and I am Gianfranco Peresutti. We're going to talk about a research we did on virtual reality technologies. It is called an analysis of their application in electronic engineering career program, as the title says. And this is a work we did for the subject of English II in the career of electronic engineering.
Throughout our presentation, we're going to talk about different topics related with our investigation. And to start with the presentation, we're going to talk about the introduction that we made to explain the idea that made us decide to investigate about virtual reality. After that, we are going to talk about the current educational context with the effects of the lockdown due to this COVID-19 virus. After that, we're going to introduce the concept of virtual reality and some kind of technology that are available to use. And to continue with virtual reality, we're going to make an analysis of the reason to use virtual reality and the problems of virtual reality. After that, we're going to present some example of use of virtual reality in electronic engineering career programs. And to finish, we're going to make a conclusion to close the ideas and the concept of virtual reality. As you know, in the early 2020, a virus called SARS-CoV-2 or COVID-19 causes most countries in the world to decide to implement a strict social containment, such as the closure of educational institutions. This strict social containment started in China, but we are a global society, so these measures expand to all the world are equal to the virus. These measures have some problems, especially with education. The United Nations Educational, Scientific and Cultural Organization, UNESCO, states that because of the pandemic in April 2020, 92.32% of the schools were completely or partially closed around the world. You can see this information in the image. So the countries that are blue indicate the schools were completely closed, and the countries that are light blue indicate the schools were partially open or partially closed. That is the same. The other problems related with the lockdown is the lack of access to face-to-face interaction. That has many problems. Among these problems, you can find the increase in stress level, anxiety, and depression, in particular in university students. What is virtual reality? Well, based on the article of University of North Carolina, the virtual reality is a responsive virtual world in which the user is immersed and have an experience very realistic. And why we decided to investigate about virtual reality. So we think that virtual reality can solve the problem of lack of access to face-to-face interaction, and this can help to develop some competence that are very important for engineers, like communication. Like us, communication, teamwork, project management, self-learning, leadership, and among others. And we think these competence are not teaching efficiently with the current methods. So we think virtual reality can solve all these problems. The lockdown due to this SARS-CoV-2 virus brought many problems, especially in highly complex career programs like electronic engineering, for example. The numerous studies about universities revealing the increase in stress levels, feelings of anxiety and depression in university students. And in general, according to a study carried out by the Shanxi Medical College, when faced with public health problems, the mental health of students suffers greatly and need attention, support, and assistance of the societies, college, and families. And this is related to the fact that around 24.9% of the students of university have experienced anxiety due to the pandemic. So all these problems are impact directly in the efficiency of learning of the student. And other problems that the students have are pure educational performance than before. So many students are getting lower grades as well as failed more tests than before. The other problem is the students have to do most of their non-theoretical tasks and in software of simulation. And these simulators are based in an ideal mathematical algorithm. And these algorithms are very far for the circuits in a real life. So the learning based on simulators is not efficient with the learning with real circuits in real life. Another problem is the lack of supervision. So some of the non-theoretical tasks or the laboratory experience have the option to do with a prototype or with circuit and a prototype and a protoboard. The problem we do this practice in their home is the lack of supervision that leads inefficient learning, and the problem of the students don't have all the measure of safety in their homes. The last problem is that the simulated practice and the practice with prototypes or with circuits in protoboards are very far for the real job of as a real job as an electronic engineer. So this difference is very important because the university prepares the students to the real world jobs.
To tackle some of the problems that my colleague mentioned, I'm going to make use of some of the papers or research we found about these topics. To start with, I'm going to refer to Koreski and colleagues that in 2011 compare the experience in a real laboratory with the virtual laboratory. For those who don't know, a virtual laboratory is a laboratory in a virtual reality world where all the equipment is simulated by computer. And the advantages of this is that students can break or get hurt by using this equipment. So makes the students more confident in experimentation. And this led to the conclusion in this paper of better experimentation and critical thinking. The next paper I first need to explain a topic. What is cognitive load? Well, cognitive load is the energy and stress the brain needs in order to learn a topic. It's explained in the cognitive load theory. And why is it important? Well, the best learning process or the most efficient ones are the ones that use the less cognitive load to explain the complex topics. And as the University of Chitkara explains in its article, virtual reality environments reduces the cognitive load that is needed to learn some topics. And an example of this can be the article published by Salzman and colleagues, where they present a complete virtual reality software to explain Maxwell laws and Newton's laws. And why are these laws important? Well, these laws are important because they are the base of a lot of engineering careers. And these laws explain 3D topics, 3D electromagnetic and gravity phenomena in equations. But in traditional teaching, these equations are explained in a 2D representation, which is inefficient, as Schnabel and Pan explains in its article that 3D arrangement topics are better explained in a 3D spatial world. To finish with this, I'm going to mention that even though all this evidence I presented, it is not enough to say it's the absolute answer to all the problems mentioned before. But we can say that we can see it as a possible solution. In the next slide, I'm going to talk about virtual reality in the present. First, the economical problems. Virtual reality is very expensive nowadays in comparison to other training, to other learning process. But as it is a technology in development, we can say that, or we can deny that in the future, it will become more cheaper or affordable as in learning tools. Between the most common or most popular devices of virtual reality, we can find first the VRH, which stands for virtual reality headsets. Virtual reality headsets are very well known because of the video game industry. Its advantages comes from its noise cancellation, which brings a huge immersion. But it also has a disadvantage, and it is that it can only be used by one person at a time. The average price nowadays for a virtual reality headset is around $70. Then we have augmented reality, which is a way of experience a virtual world through a device. And the advantage of this is that we can have it in every device that supports a camera. Augmented reality has also a disadvantage, and is that it's not immersive at all. Then we have CAVE automatic virtual reality environment, which abbreviated is CAVE. It's a set of between 5 to 7 projectors that project an image in all the walls in a room, and this have the advantage that can be super immersive, and also it can be used by a group of people. The only disadvantage is that it's very expensive. So what to choose? Well, it depends. Some topics don't need a lot of immersion, and some topics don't need to be explained to a group, and can be explained to one person at a time. And now we are going to see some videos of each of the devices so as to get a better understanding of how they work.
Great. Now, grab an AC/DC voltage tester from your tool belt. Take the test leads in both hands and connect them to the highlighted markers on the circuit breaker panel, and check if there is a live voltage. Now, when we figured out that the circuit breaker panel 1 is energized, we need to search for the isolation point for this panel on a single line diagram. Teleport to the objective marker near the single line diagram on the wall.
Now we will see augmented reality. And lastly, the video of CAVE.
The next topic in the presentation is the example of virtual reality implementation in engineering career programs. We choose these two examples because are related with the electronic engineering career programs, because this topic, robotics and engineering laboratory, are essential for the education in electronic engineering career. The first example is about teaching robotics programming using low-cost VRH And the second example is about enhancing electronics engineering laboratory experience with the implementation of virtual-based learning environment that we named VLA. The first example is about teaching robotics programming using low-cost virtual reality headset, VRH. In general, as reported by the article of University of Alicante, when it comes to robotics class, few issues to consider from an educational standpoint. These are cost of robotic arms, space required by robots, and the safety problems due to inexperienced students. All these problems can be solved with implementation of virtual reality. Let me explain. You have a virtual reality headset. This headset send the information of the position of you and your moves to the computer. The computer analyzes the data and the information and move the virtual scenario that you can see in the image. This image, the rendered 3D image, sent to the virtual reality headset. And so you can view the virtual world at real time. And as you can see in the image, the virtual world is very similar to the real world because the robotic is exactly equal to the robot in the industry, and the work zone is equal to the work zone in industry. And the very low cost is because to the implementation of this method, you can use a Google Cardboard glass that is a virtual reality headset that costs around $5, and is for this reason that is a very low cost virtual reality headset. You only need a computer to run the software, generate the 3D models, and a smartphone that you can use in the Google Cardboard inside them that use a screen and use the accelerometer and gyroscope to sense the position of you and your moves and send it to the computer. And so with this system, we solve the problem of cost of robotic arms because you don't need a robotic arm. You can use in the next stage of learning, but for do tests, you don't need it. Solve the problem of space required by robot for the same reason that I explained before. And we solve the problem of security because the students program the robotic arm, send the program to the virtual world with the virtual reality headset. So how a robotic arm move and do the task with the program that they charge to do the robot. So all the tests, all the proofs are taken in a virtual world, so the risk is 0. The next example is about enhancing electronics engineering laboratory experience. For this example, the University of the Chitkara University implement a virtual reality-based learning environment, VLA, to teach to students how they must operate the function generator and the oscilloscope that are two instruments essential for all the electronic engineer career. In this case, the system of virtual reality helps students to learn about the instrument, learn how they must operate, and allows the student to engage with 3D models rather than the real ones, giving them confidence in the ability of manipulate the oscilloscope and the function generator. This is very important because the instruments in the real life are have a cost higher, and in the virtual world, the student don't feel the fear of break the instrument. For finish, we can say the virtual reality technology is an opportunity to improve the electronic engineering career programs, and is a technology very new for this topic, and it can be used for another topics of education. We can use as the kit in the image for mechatronic or mechanical engineering, for example.
Well, that is all, and thanks to everyone who watched the video. And you can watch the paper we did, where you can find more information about this, and all the papers and articles we found in topics in this topic. And now, well, close this presentation, thanking everyone.